shadow of the crew falls in yet another direction because of the hill.
These results directly contradict the conspiracy claims.
Like the Apollo astronauts, we had to guess at our focusing distances and our exposure settings. And because we had no viewfinder, we had to guess at the direction the camera was pointing. And you can clearly see that even with those handicaps, we were able to take quite usable photographs. You can immediately see that there are no stars in this photograph, even though the stars were very bright during our experiment. They're simply too dim to be registered on film at the exposure levels that we used to take these photographs.
The results of our photographic experiment appear to be overwhelming. But the mysterious image of this rock in an Apollo 16 photograph seems to back up conspiracy claims that all the moon landings were faked.
It's a rock that obviously was made out of paper mache, and very clearly on the rock is the letter C.
In Ralph Renee's mind, the C rock should be called the C prop.
Somebody told me that in Hollywood, when they do a set, the set manager comes around and drops cards on the ground, and it says A, B, C, D, E, F, G, H, or 1 to 10 or whatever, and the prop men, whatever you call these people, they come out and they put that particular prop over the card. But in Hollywood, they're smart enough to turn the thing upside down so you can't see the mark on the prop.
NASA explains that this photo was a misprint. The letter C is nothing more than a hair on the negative. But this explanation doesn't satisfy magazine publisher Marcus Allen. He believes it's impossible that any of these photographs could survive a journey to the moon and back.
In an unprotected camera, in unprotected environment, and the films that were in photographs we have seen as a result of that, it demonstrates absolutely no radiation damage whatsoever.
In 1998, IMAX began production on a film about construction of the International Space Station.
They flew the cameras up in the space shuttle with their magazines attached, and the IMAX cameras take 70mm roll film. Incidentally, the same film as was used in the Hasselblad still cameras on Apollo. This film had to be protected, and it was carried up in lead-lined boxes.
According to conspiracy theorists, radiation was the final insurmountable obstacle. Not only would it destroy film, it would kill the astronauts. The Earth's magnetic field protects our planet from high doses of radiation. But beyond this zone, deep in space, is where conspiracy theorists believe astronauts would be vulnerable to radiation's deadly effects.
The moon is irradiated by the sun constantly with terrible heat, and of course there's cosmic radiation, and then there are micrometeorites that travel 60,000 miles an hour that would go right through the camera, the film, and of course the astronauts themselves.
After leaving the Earth's atmosphere, the astronauts rocketed through the Van Allen belts.
Van Allen, he said it was a sea of deadly radiation. You would pick up a death dose just about the time you got through the Van Allen shield. You'd be cooked and you'd be dying.
These radioactive belts form a thick ring encircling the equator, thinning out around the North and South poles.
Until they get an engine that'll lift the life capsule surrounded by 6 feet of water or equivalent mass of lead, they don't even dare go through the Van Allen shield.
In fact, Dr. Van Allen, who's still alive, makes no secret of the fact that he thinks these stories about killer radiation are silly. Entertaining but preposterous is his words. And the reason is that the radiation levels there are not enough to hurt you unless you stay there for a long time. Van Allen says about a month.
NASA claims the astronauts endured only a brief exposure, penetrating the thinnest section of the belts in 1 hour. But once they crossed through, they faced an even greater danger.
So here we have these clowns running around in tinfoil craft, stopping solar radiation. And I'm not talking about the light, I'm talking about the radiation from the solar storms.
You put a man in a powerful solar flare, he's dead. End of story, he is dead. unless he carries protection.
These eruptions from the sun can knock out satellites and electricity grids on Earth, but they can also be detected by an early warning computer system.
When you land on the moon, you're practically standing still, being bombarded with all this solar radiation that's smacking into you, which is why they had to hide the whole thing, because it just can't be done. It couldn't be done then, can't be done today, and it sure isn't going to be done in the future when they're planning on this manned mission to Mars.
Just 3 months after the Apollo 16 mission, NASA admitted that a violent solar flare hit the moon's surface, an eruption so powerful it could have killed the astronauts had they been there.
Solar flares are one of those things that you have to take a calculated risk on, because they will zap you with radiation once they get to you, but you've got a long time, hours if not a day or more, to either come back to Earth, find a shielded place, or prepare yourself.
Astronauts could only rely on their spaceship to survive a solar flare.
And they had plans for this. The plan was to turn the bulky end of the ship toward the incoming front of radiation. That bulk of the ship and all the fuel in it would provide plenty of protection for that burst of radiation.
For conspiracy theorists, radiation is the final nail in the coffin. They believe the astronauts could never have survived a trip to the moon and back. But it may also provide the key to unlocking secrets from the lunar surface itself. Can radiation supply the definitive answer to the question, did we really land on the moon? Stay tuned. More answers when we return.